This question uses trapezium rule to approximate an integral, and then we also use some log laws in the second part. Let's see how this first part works though. We've got y equals log base 3 of 2x, and we've got a table of x's and y's. We want to use the trapezium rule to approximate this integral. So if we remember the trapezium rule, it tells us that the integral I is approximately equal to, and we always have to start with a half. You can remember that because a half is definitely a part of the formula for a trapezium. The first thing we need to think about is the width of the strips in our trapezia. And look at the difference between the x values. It's always 1.5 each time. That has to be the width of our strips then. So a half times 1.5 times, and now we need to think about those y values because they're the heights of our trapezia. If you think this one on the end and this one on the end, they only feature once in each trapezium. So that's why we have just a 1.63 and a 2.63 featuring once. But all of the other points, those middle points, they feature once at the end of the first trapezium and then once at the beginning of the second trapezium, and so on. All of the three middle points feature twice, so we need to double those up. We've got 1.63, oh sorry, we already used that. We've got 2, 2.26 and 2.46. They all feature twice. At this point, it's just putting it into your calculator, and the answer that you should come out with is your integral. It's approximately equal to 531 over 40. Key things to watch out for with this are making sure your brackets are in the right place and you close the brackets that you've opened so it all comes out neatly. Okay, that's our first integral then, and it's worth us thinking about how this relates to the second part of the question using log laws. So we've got the integral between 3 and 9 of log 3 of 2x, and we're interested in how this relates to the integral between 3 and 9 log 3 of 2x to the power of 10. And if we think about log laws, well, this power can come down in front of the logarithm. They're equal to each other. So what we could say is this integral here between 3 and 9 of log 3 2x to the power of 10 dx. Well, this 10 could come down to make it 10 log 3 of 2x, but actually it can come out the front of the integral. Any scalar multiplier like that can just come out to the front of the integral, and it makes no difference if it's inside or outside. So we've actually got 10 lots of the integral from 3 to 9 of log 3 of 2x. So let's write that down. Log 3 2x dx. And what's really important that we see in this question is, we've manufactured this on purpose because we already know the value of that thing. This is what we worked out in the first part, 3 to 9 log 3 2x dx, and we know it's 531 over 40. So we can write that in there, 531 over 40. Well, now all we need to do is we've got 10 lots of this thing, so our answer for this part should just be 531 over 4. Our denominator gets 10 times smaller, doesn't it, when we multiply the fraction. Great. Now on this part, we've got, let's underline that as well actually, so we make our answer really, really clear. On this part, we've got between 3 and 9 log 3 of 18x. So what's changed from what we had earlier was we used to have 2x inside of our log. Now we've got 18x. It's worth us thinking more about log laws and how can we relate the 2x to the 18x. Well, we know that if we have, so log A plus log B equals log AB to the same base. That's exactly what's going on here. We've got log 3 of 18x, which we could write as log 3 9 plus log 3 2x. Can you see we've deconstructed our log 3 of 18x into log 3 of 9 and log 3 of 2x. Those come together to multiply to make 18x. So actually what we've got then is an integral from 3 to 9 of log 3 of 9, which is actually just 2, isn't it? Because 3 to the power of 2 is 9. So 2 plus our log 3 of 2x dx. So this is our integral we want to find in this part. Between 3 and 9 of 2 plus log 3 of 2x dx. And if you think about this, we've got 2 that will integrate to 2x, and over this distance of 6, 2 times by 6 is going to give us 12. We already know this one from earlier as well, don't we? Log 3 of 2x dx gives us our 531 over 40. Plus 531 over 40. At this point, we could combine those into one number, but that again is just something you can do on your calculator. So I'll leave that bit to you.